Behold, in front of you, you have this really large number. It's into billions. Have you ever counted this high? Of course not, but you understand the number because you understand place value. Now, what is the largest number used there? It's a 9. In Mortensen math, in base 10, we say you never count past 9. When you have 9 and you get one more, you get the next largest kind. Let's do that with our units. Picking them up, let's put them in. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we never count past 9 because what happens if I were to put one there? It would be just the same as 10. When we have 9 and we get one more, right here, one more, we have one of the next larger kind. We have 110. We can do that same thing with our 10s. Let's drop these out. 1, 2, 3, 4, 5, 6, 7, 8, 9. And what happens if I put one more in? That's just the same as 100. We never count past 9 because when we have 9 and we add one more, that gives us the next largest kind. In this case, 100. Let's use our tray and do something else. Now again, I'm starting out with it empty. With the younger children, it's nice to start out with it empty. That way there aren't a lot of distractions. I've put a 7 in. Can we build a 7 with a 6 and something else? Can you find the piece that will go with the 6 to build 7? Of course. It's a 1. And the tray is self-correcting. It's so easy for the child to succeed. Can you build a 7 with a 5 and something else? Right, a 5. And what will go here? A 2. Now, can you find a 4? And what can we put with 4 to build 7? A 3. Well, what if we start out with a 3? What would we put with a 3? The 4. Now let's try a 2. What could we put with a 2? That won't work. And you know what's going to happen? The child may pick it up and start to put it there, but immediately it's very obvious. It's visually obvious. This doesn't fit. They get it close. They put it away. They've corrected themselves. Now, they can build a 7 with a 2 and a 5. And what if we started out with a 1? What would we use? Let's see. I bet this will work this time. It does. Notice that here the child sees a 6 and a 1 and a 6. Both of them give them 7. Very important concepts for children to understand. If they have the experience first, then later when we attach fancy names such as the commutative property to that, it's going to mean a lot to them. Think about learning just about anything. I've done workshops where I talked to people before I ever went to that workshop. I was very familiar with their names. And in spite of the fact that there were 40 or 50 people at the workshop, it was very easy for me to call them by their name after just a few minutes because I could attach the name that I had heard over and over again with that face. It's a lot different from walking into a workshop and not having ever met anyone before or not ever having heard their name. When we know something, then just adding a little bit more makes it easier. Also notice that I use the word build. We can build a 7 with a 6 and a 1. That's a child's language. After you say that, then you can add those words plus and equals. Note 2. Let me write this. What does equals mean? Equals means the same as. Does this look the same? Now be honest. Imagine being a young child. Does this look the same? No. But let's put the bars there. Here's a 4. Here's a 5. And here's a 9. Are they the same? Well, if we push them together, the child can see that it's the same quantity, it's the same length as, that these are the same. And you know what typically happens even before that? Children working with the blocks will discover that if they put a 2 with a 3, that's always 5. Always. It's pretty powerful when the child makes that discovery. Right now it seems minor test, but take the time and think. That's very powerful for the child.